Hi Nilesh, welcome to the podcast. Super happy to have you here.
Hi Tejas, how are you?
I'm doing well. So I'm actually happy to have anyone on this podcast, but since I already know you from college, it's even more exciting.
Yeah, it's been nice to know you and you are doing great in TI, right?
Yeah, yeah. So for the viewers who don't know you, how would you like to introduce yourself?
Yeah, sure. So, hi everyone. So, this is Nilesh and I completed my bachelor from National NIT Kurukshetra and MTech and PhD from IIT Kanpur in electrical engineering. And right now I am a postdoc at University of Texas at Austin with Dr. Sanjay Banerjee.
Okay, that's quite brief. So I think
Yeah.
that was a humble introduction.
Yeah.
So for the viewers, he had a very successful PhD at IIT, and he was also invited to Stanford by a talk, right?
Yes, we can discuss it like in the podcast, so we will discuss each of the points. I just give a brief introduction, so.
Right, right. So I think until now everyone might be thinking that why did you pursue a PhD in India? So let's
Okay.
just dive right into it.
Okay, sure. So actually, what happened that during my undergraduate days, so I got interested in the mathematics and analytical modeling. Maybe my from UG third year or fourth year. So at that time, I started to work on a problem that was involved in mathematics, green function, and analytical. So somehow I was able to do some good work, and it got a publication in my UG year at IEEE Transactions on Electron Devices TED. So I was really sure from my third year that I am going to do PhDs. But and I was also sure that I am going to do the PhD in the device modeling area because in electricals, like in semiconductor, we have broadly two areas if we want to divide in VLSI. One is devices and another one is circuits. So I was sure that I have to do the modeling. So then I started to look into the group that who are doing the great work in India and also in abroad. Of course, in abroad like in US, UCB and EPFL, MIT. Of course, they have like really great professors those who are working in the modeling. In IIT Kanpur, there is a professor, Professor Yogesh Chauhan. He did his PhD from EPFL.
Mhm.
So he's really pioneer in the modeling. So
Right.
everybody was knowing from his work. He made his name from all over the world in the IEEE ADS community. So I approached him. So like our research interest aligned. So he also agreed that I will be able to continue my work. I will be able to explore my own work, my own ideas in the device modeling. So that was a really good point for me. That okay, I thought that maybe I should consider to do the PhD in India. Then after that, the backbone was that PMRF, Prime Minister Research Fellowship. So actually, I got that PMRF in 2018. So it was like quite a good stipend, like around 1 lakh per month, and there is no tax
Right.
because that's a fellowship. So I applied for that PMRF, and at that time they used to take the interview. So there was an interview panel. So it was a thorough interview, and fortunately my publication helped me a lot, and I got the PMRF funding. So financial thing also got sorted out. And not choosing abroad, there was one more reason that uh, see abroad okay there is you get the funding, but of course you have to spend a bit. So like it's like you have to take loans. So it doesn't matter that whether you get the PhD funding or not. It's like so I thought maybe it would be more financial, and of course I got the good group and the good finance, so I chose the IIT Kanpur.
So before joining IITK, were you sure that you would get a PMRF, or did you plan for it after coming to IITK?
Yeah, actually, that was kind of, I would say, it's kind of fortunate because when I planned to join the IIT Council for the PhD, at that time PMRF wasn't like, they haven't had any scheme for the PMRF. So they initiated that scheme in 2018 in the July, and I was in IIT Kanpur interacting with Dr. Chauhan from January. So I was sure that I'm going to apply in IIT Kanpur for PhD. So I was
Okay.
thinking maybe I will apply for the normal PhD, of course, but fortunately they launched the PMRF. So I also applied for that, and I was sure that I was mostly sure that I will get the PMRF because at the UG I had the publication that really helped me a lot.
Yeah, yeah. So for PMRF, you mentioned there was one round of interview, and was there anything else, or how was the process like?
Yeah, so actually now there is a process has been changed. So earlier when they started the scrim in 2018, so first thing was that you have to write your SOP, your CV, your research profile, and they will review it, and they shortlist some candidate. And if I remember correctly, from all over the electrical engineering, they shorted maybe I don't know how many, but they only selected 120 something like that in all branches in
Okay.
PMRF. So after the shortlist, there was an interview. Unfortunately, IIT Kanpur was the nodal for electrical engineering. So all the professor, I think in my panel, there was a professor from ISC, one was from IIT Bombay, and one was from IIT Delhi, and one was also from IIT Kanpur, and I think from Control, yeah. So they all took the interviews, and they started from the UG concept also, because that PMRF was like to get direct PhD after
Right,
your
right.
UG. So they also asked me some basic concept like professor from control. They asked from the control theory. They also discuss about like analytical skills and mathematics. Then they get back to my papers. Then they discuss it thoroughly. So that was the process at that time. But right now there is no interview. Right now, firstly you get your PhD admission in any IITs. Then you apply for PMRF. Then after that they will shortlist you based on your SOP and your resume and your works. Then they will decide whether to give you PMRF or not.
Right,
So right
right.
now that.
So, for anyone like who's right now a student at a top institute in India, would you recommend him to pursue a PhD in India, or do you think they should go abroad?
Yeah, actually, that's a really good question. So, see, everybody wants to go like explore outside. So everyone wants to go. Okay, we want to go the elite institute like in US, and of course in US, I feel that most of the engineering people will choose the US because it's like everybody used to be MIT, Stanford, everything is here. So, but the thing is that I would suggest is suppose there are domains in the electrical engineering. I'm going to just discuss about the electrical domain. So if you are not going to do like much experiments, like I would say, if you are not going to fabricate device like semiconductor transistors or
Right.
analog circuits also, I would say. So if you want to like pursue the theoretical domain, like device modeling, and maybe some architecture level design so that can also they are really good opportunities in India if you get the PMRF, and you can really save a lot and you can really do good work in the PhD if you are not going to get involved in that much in experimental domain, because in experimental India is doing now started to do like IIT Bombay is doing really good, ISC also a really good lab. So yeah, like if you want to do in India, then maybe best option should be IIT Bombay and ISC. It's a really good thing if you get PMRF and you continue with it. I think it would be a nice choice.
Right, right. I mean, the stipends are like comparable to what the industry offers, like the
Yeah,
top companies here, so it's quite good. And
yeah,
also
it's
the
no
cost
tax
of living at campus is like very little. So,
and
so
it's no tax. So yeah, I can tell you my personal experience. So whatever I was getting, so like there is no hostel rent, it's little to no bit, right? And there is no mess food or something like that. You only spend maybe 4,000, 5,000 per month. The rest
yeah,
if you are not doing anything, like of course we are doing until let's get it local, you spend 10,000, 20,000. Then also you can take home 70,000, 80,000.
yeah, yeah,
So
that's true.
per month. So it's
And on
like
top of that, you also get some amount for conferences or
yeah, you are
additional amount.
right. Yeah, actually there are amount every year you get 2 lakhs. 2 lakhs every year. So by that amount you can travel abroad or maybe national conference, and you can also buy for yourself laptop, iPad, this kind
Oh,
of things.
okay, that's pretty
So
cool. Yeah.
yeah, I
So,
also bought a laptop and iPad.
okay.
It's
So,
contingency fund. They call it contingency. Yeah.
what do you think are the post PhD options? So you yourself went for a postdoc, and
Yeah.
but typically, let's say you pursued a PhD in India, like you did, and then what are the next possible options, and how what things can people go for?
Okay, so I will be focused on the electrical semiconductor
Yes, yes.
domain. So because that is my expertise. So I feel that if you did you do your PhD from India, it doesn't matter if you do even PhD from abroad and you try and you start want to come back to India. So in Indian semiconductor industry, so there are R&D, but it is more centered to the circuits domain, like Texas Instrument, AMD, analog devices. Like in circuits, you can do the R&D, because in circuits, like you have to do like in the tools, and you have to think by yourself. You have to use your mind
Right,
like
right.
something like that. But if you want to do like R&D in the devices level, so in India there is no fab still. So it would be
Hmm.
really hard if you want to do like if you want to fabricate new device, if you want to analyze new material. So if you are interested in that kind of jobs, then definitely you have to go outside, because these jobs are not still in India. Maybe the nearest place would be Singapore, because Singapore they have global foundry, they have foundries
Yeah.
there. But yeah, if you want to really work on the devices R&D, I think US would be the best place. That's why I also opted for the postdoc, because when I came here, so maybe we can discuss it later that how it's going on. But yeah, if you want to explore more in the R&D level of devices, you have to go outside of India. For unfortunately, that is the
And
scenario.
how difficult is it getting a job abroad right after a PhD, like in device modeling?
Yeah, in device modeling, right after PhD in US, it's really hard because see, if you look on the group in the US like Intel, TI, and for the devices group, like they have two kind of group TCAD, like look, people do the computer
Yeah.
aided design, and another one is device modeling group, like those are only focused on the modeling domains. So their group is only like 6, 7 people, 8 people. So
Hmm.
they only there is a vacancy only maybe after 1 year, 2 year they only hire one to two or three people, something like that. But they really appreciate our Indian PhD. Like I discussed with those guys. But thing is that there is a visa issue directly hiring from the
Yeah,
India
yeah.
for the industry job. So initially they like they insist to that maybe you come to US join as a postdoc something RA something like that. After you spend 1 2 year here, then there is really easy process to for the visa issue.
I
So
see, I see. And do you know about Europe? Because I think Ravi, he went to Europe, right?
yeah, he's in Munich in Infineon. Yeah, Infineon.
Right, right. So are you aware, like, is it like the same for Europe or it's easier to get a job in Europe?
Yeah, actually, Europe, US, what's happening like in the US, you have a lot of competition. Like everyone is applying for these kind of jobs. So
Yeah.
they like I would say that it also depends on relative applications. So when they come that many application, then they try to sort out the things. Suppose you have a candidate and another candidate is from US. So maybe if you candidate from US is not that good as much you, but it's like it's difference only 9 10 they will prefer the US because there is no issue with the visa and
Mm-hmm.
also
Right, right.
companies have to finance you. So it's like financing the candidate. So I would say getting in Europe might it's in on the overview from my thinking. I think getting job in Europe it's a bit easier than getting job in US in the semiconductor and electrical engineering. That I
Right.
would say.
Okay. And you mentioned about fabs. So do you ever see a fab coming to India in the near future?
Yeah, actually, that's a really tricky question. So I fortunately I think because from last few years the Modi government is started to like they are really looking into it. They started the mission Semicon India. Have you heard about it?
Yeah, yeah, yeah,
There is
yeah.
a mission going on Semicon. So they are doing regular meeting and right now, in the recent news, I heard that Tata Electronics is going to invest. That they are going to make a fab. Maybe in Assam, Gujarat, I'm not sure, but yeah, they are trying to make a fab. It's not going to be like state of the art, like 5 nanometer, 10 nanometer. That is
Mm-hmm.
not going to happen. But it might be like 65 nanometer or 18 and 90 nanometer, something like
Mm-hmm.
that.
Okay.
So yeah, we really hope so. But they are trying to do some good thing. It's really costly. Like they have to spend billions of
Yeah,
dollars.
yeah.
So I can
Yeah.
understand that.
And also in India, also there are some good companies and devices, right? Like I think Micron, Global Foundries, maybe Intel as well. Uh, so what do you think about jobs right in these companies, or do you have any idea of how it is there?
Yeah, so right after PhD, so suppose you do somebody did his PhD in device modeling. They're like, I'm not talking about the experiment. Like you stick with the theoretical one for the Indian
Right.
job. So yeah, so even after PhD, I know many like many of my colleagues, my seniors went to join to Microns and like Global Foundry, and they are really getting paid really good salary. So I would say it's like maybe they are getting their CTC might be starting CTCs might be 35, 30 lakh something like that. It's the starting salary. So in India, yeah, they
CTC
are.
or base?
Yeah, I would say that in hand, whatever they are getting, if I'm not wrong, I'm not, don't remember correctly, but I think it's maybe you get 2.5, something like that in hand.
Oh,
Like at the
okay.
starting of the time, 2 to 2.5. It depends, like
Yeah,
every
yeah.
group has their own kind of like pay scenario. But yeah, like Micron is also paying really good. Max Linear, there is one company that is also really paying
Max
really
Linear
good.
is hiring for devices?
Yeah, they
Oh, I
also have
didn't. I
device.
thought it was just RF circuits.
They have a small group for the devices. Yeah,
Oh,
they
okay.
have. And the Synopsys are also starting their TCAD group in India.
Right. Yeah.
I discussed from US people there from a TCAD guy in the Synopsys. So yeah, they are going to like centered in India. They are going to expand their team in the TCAD. So they will also pay very really well. So that's a really nice option. If you spend your PhD, you do your PhD like in device molding, you can finish your PhD wrap up soon. Like in the early stage, maybe 3 or 4 years, then you can get a good job if you want.
Yeah, I mean, yeah, so this is also what I wanted to ask. So usually, in like research particularly, you can't, decide that you want to finish in a certain amount of time because it's sometimes it's not in your control, right? Because it's research, things fail, things don't go as planned, and so on. So, what do you think, like, about papers and let's say I want to target top tier journals. So first question would be how much does the impact factor of a journal matter? And how do you
Okay.
decide between journals and conferences where to submit a paper?
Okay. So impact factor of the journal, see what depends. It depends what kind of work you are doing. So suppose you are doing theoretical work, you are not involved in the experimental domain.
Mm-hmm.
So you cannot target like really high impact factor journals like nature, electronics or nature, or these are really they have impact factor 60, 40, something like that. So, and if you read their overview, see, you can still publish in those journals from India if you are doing in experimental work, but they really don't want any theoretical work. Like if you are not doing any breakthrough, like solving a Schrodinger, driving in another Schrodinger equation, then
Mm-hmm.
okay, definitely that might definitely they will accept it. But they refrain themselves. They want to stick to the experimental domain. And in the theoretical domain, there is a prestigious journal IEEE Transaction Electron Devices and Electron Device Letters. So even people from, if you see that those guys working on device molding, it doesn't matter whether you are in from US, MIT, Stanford, or EPFL from Europe or India.
Yeah.
They all publishing in IEEE TDS. So that is their top prestigious, and that is values a lot. Like if you publish three, four papers in your PhD, that is considered a really good PhD. Like okay, you did your good work. And for the conference, there is a conference, IEEE Electron Device Meeting. People call it IEDM. So
Idea.
maybe
Yeah.
that yeah, that's a really prestigious conference. It happened December in San Francisco. So yeah, if you got your paper, if you got only single paper in that, like my supervisor used to told me that if you got a single paper in IDM, you are done with your PhD, something like that.
Okay.
So
So yeah, but how do you decide like should you submit to which journal or which conference, or let's say you did some research, how do you decide if you want to submit to a journal or a conference?
yeah, actually that's the choice on the, I would say, the person who is doing. Suppose conference, the target of the conference is, if it's a good conference, I would say like IDM, there is another one, DRC, Device Research
DRC. Yeah.
Conference. Yeah, so the target of those conference that you want to interact with the people, you want to show your work, and you want to make networking. That is the whole purpose of the conference. So if you want to like, if you did some kind of novel research, and if you want to like to show it to people to as soon as like want to discuss with industry and with the professor, then conference would be a nice thing to do.
Okay.
Suppose if you get a paper DRC IDM, it is equivalent. It is maybe it's not, maybe it's higher than TD, I would say. So it's like it's so if you, and it's also give you opportunity to like discuss with people, with the industry guys, and for the journals, it take times. It will take maybe 4 5 months. I would say if everything goes smoothly. So like you submit, you get revisions, you have to fight with the reviewer. Reviewer is always
Yeah,
there.
actually, I just got a revision last night from TED.
Okay. So how is the reviewer too?
I I'll have to plan the rebut now because all the three reviewers gave, I mean, a lot of comments actually.
Yeah. So actually, it's what happened. Most of the time, the reviewers are some academias like professors, so something like that. So when those guys get paper, so what I feel that the mentality of the reviewer is like they don't want. They initially they just make a base mentality. Okay, I have to reject this paper, something like that. So they try to review in that manner. Okay, what are the culprits in this paper? But of course, if you got the revision, like you got the revision, right?
Yeah, yeah.
Yeah, so it's like it's a nice opportunity. They are giving you a chance to explain yourself. So you should be
Mhm.
like really thorough. So I think after 1 to 2 revision, they will accept it. That's why I told you that it's like a publishing a journal. It's like 5 to 6 month time
Right,
period.
right,
Of
right.
course, meanwhile, you keep working on another works, but publishing in one journal. That's why like publishing 3 4 journals it take 3 4 years.
Mm-hmm. Got it. Yeah. But you'll also have to have three, four different experiments or research works, right? So how do you
Yeah.
get the time for all? And you, I think, published a lot of papers, not just four. So how did you get the time to like write? Because even paper writing takes time, and then also going to conferences, conducting your own research, and all of these things all together. I think it's a big thing.
Yeah, I think the answer is like yeah, it might be a bit thing. The answer is like you have to work hard in your PhD. Like I'm sure that you also did when you are preparing for JEE.
Yeah, yeah.
Like getting into IIT is like electrical engineering for the BTech. Like it's really hard. Like you have to work hard. So in general, like when you submit a paper, so like you will get the response after 1 month, 2 months. So you keep working on another things, and how the another things comes, it comes with the discussion with your supervisor, with your colleagues. So and with going through the literature. So like so most of the time, how the people write their paper, when they conclude their thing in the paper, they also mention some kind of future scopes, like what
Mhm.
to do. because nobody going to solve everything. So it's like incremental work. You are not expected in your PhD that you are going to get a Nobel Prize. You are expected that you are going to do some like incremental things, and so that is the thing. So from there you can get the ideas. Like when you try to read the paper, try to discuss with people. If you read many papers, it will also give you the idea that how to write a paper. When you read all, it's an
Right.
art. I would say it's an art. It's not like it's not a technical. It's a technical thing, but it's an art. So when you get familiar with it, you will start. It will only take few days.
Right, right. And in your PhD or even now, do you like think that you want to publish in this journal and then you start your work, or your research is more of like a byproduct of what you're doing, and then later on you just see, okay, I can submit it here.
Yeah, actually, so how I plan that initially I don't target usually that which journal I'm going to submit. So it's like depends on work or quality of the work. So what kind of quality we so after the work is done, when we discuss with the supervisor and all other colleagues, then we try to like they are also very experienced. So after the work, having your a draft of the paper, they really can judge it maybe in 1 to 2 days. Okay, this journal we should target because there are journals that they follow their own guidelines that which kind of paper they want to accept they want to do.
Hmm. Right,
So
right.
yeah,
Okay, got it.
research is
So,
the main where output depending on the outcome you can decide which journal you are targeting.
yeah. And did it happen? I don't think it did, but did it happen that you were just struggling to get some ideas or solve some problems, but you weren't able to solve, and then it's like you didn't have anything in the start.
Yeah, actually, it happened. It happens a lot. So I would say that even when I started to work on problem in my UG days, so that was an approach to solve a two-dimensional like mathematical equations in analytically. So it took me initially, I would say maybe 1.5 year to solve that accurately. So yeah, I got stuck a lot. I have to like it's like failure every time when I suppose firstly I solve the equation, then I try to write in the MATLAB, then the potential is MOSFET potential is coming 10 raised to power 9, something like that. So of course it's not going to happen, right? So for this series were not converging, then I have to go back and see everything. That's the how the research work. You start from something, and definitely you are not going to get success in overnight or maybe in 1 month. So it will take time. So then you rectify it, then you again do it. Yeah, you have to
Yeah,
do it.
that's how it
There is
is.
no shortcuts.
Yeah. So, so okay, we'll get to your EDS fellowship. So you got the
Yeah,
EDS fellowship for your masters as well as for your PhD. So,
yeah.
how was the process like? And for the people who don't know, what exactly is this EDS fellowship, and what are the benefits of it?
Okay, so EDS means Electron Device Society. So that's a society of IEEE. So there are two fellowships. I think there are three fellowships. Yeah, for the student. One is undergraduate fellowship, IEEE
Yeah.
UG fellowship, then IEEE EDS Master's fellowship, then IEEE EDS PhD fellowship.
Hmm.
So what the IEEE means that they say that they are a non-profit organization. So they try to like issue this kind of fellowship to like motivate the engineer from the devices in the devices. Yeah, it's focused on the devices. So it's not focused on the circuit. So they try to motivate the people like okay, you want to do your PhD, so how you can get the recognition. So for the master student, I think for the world level, that is the most prestigious fellowship, IEEE EDS Masters Fellowship. So from all over the world, people apply for that, and I think it's $2,000, and
Yeah.
whoever gets it, and the process for is like, of course, you have to write a SOP, you have to write such proposal, and for the EDS Masters, if I remember correctly, you have to apply within 1 year when you join the master's program.
Hmm.
It's
Yeah.
there is a deadline that you cannot apply in the second year. So they will judge you. That there is a committee from the devices level. They will judge you depending on your CV and research proposal and research work. In masters, they are not really focused in that much unknown number of publications because they know that you just finish your UG and you are doing your master. You
So
won't be
even
doing
if you
that.
have like one publication, it would really strengthen your.
Yeah, yeah, you got the nice point. Yeah, you mentioned the nice point. That's how I got it. So I understand. That's how I feel. That's how I got it. Even if you have one publication in your UG, so they will really consider you like, okay, you are above many other candidates. So they will really consider for the master, and for the PhD, that's a really like it's a much higher level. In that PhD fellowship, you get $5,000, and they also invite you to attend the IDM. So they will
Yeah,
give
at
you
San
exposure.
Francisco.
Yeah, San
So
Francisco
do
and
they
everything.
also fund your flight tickets, or that is on
Yeah.
you? Oh, they fund
Everything,
them.
they everything is paid. Even your stay at the Hilton is also paid.
Oh, that's really cool.
So it's a really good fellowship. So because that is fellowship is again for the students. So they are not expecting student to spend like $5,000, $6,000 on tickets and hotel stay. So they will pay everything and they will also give you $5,000 and you will be like awarded in front of all the IDMs guys and every industry. And of course, that's a really good scenario. But for the PhD, there is really hard competition because they will only choose maximum one from US and Canada, and maximum one from Europe and one from Asia Pacific.
Hmm.
That's their criteria. So they will only choose maximum three candidates from all over the world. So that is how it's happening. So in India, I think somebody is targeting for the EDS fellowship. I think the right choice would be to stay in the molding area. What I would say, like it stay in the theoretical domain or maybe in the circuit domain. Because in experiment you have to do like publish really good paper. Because I have seen an experiment where people got EDS fellowship. They were publishing their paper in Nature, something kind of these kind of things,
I
Nature
see.
Science. So
Yeah.
because in experiment they are expected to do you publish in a good, really reputed journal. See, I
Hmm.
didn't had any nature publication, something like that. I only had TEDs. So TEDs and ADL. That also got me to for the EDS fellowship, EDS PhD fellowship. So
Yeah.
those guys also know that which kind of work up to which journal you can target to the maximum. They know that.
Right, right. And okay, so now that you're at postdoc at UT Austin,
Yeah.
how different do you think the environment at Austin is from let's say Kanpur or at IIT Kanpur particularly, and how do you like it over there?
Okay, okay. So actually, I'm at UT hosting. So I joined Dr. Sanjay Banerjee. So he written a book like that. That's really famous. Like solid state
Yeah.
devices, treatment and energy. So everybody read that. So he's like really good person here, and he's my supervisor. So the really difference, I would say that I would say the coursework in the IIT Kanpur in the prestigious IIT, I would say that are equivalent to the what in the US. So they are really trying to follow that. In IIT, I really love that thing. That when I was in an IIT, I won't say I would be honest with you that coursework was not really that good. They were not designed to give you that flavor. But in IITs, they really designed to give you the flavor of the MIT and the UCB. It's really they are really working for the UGs. They are really designing a really good environment in the IITs. I'm sure about the old IIT. I'm not sure about the new IITs. And for the research thing, again, research thing theoretically you are doing, again, that is because most of the professors in IITs, they did their PhD from like abroad. So that is equivalent, I would say, in academia. But the really difference when what comes then how you collaborate with the industries.
Hmm.
So here the industries, but because you are in US, so that's a really big advantage for you. So industry
Yes.
base in US like Intel, IBM, TI, they really approaches automatically to the professor to you. They really want to give you the R&D work. So that's I would say that is the most important benefit which I got here. That now I am interacting with the industry, the R&D guys, R&D people. So
Hmm.
that would be possible if I stayed in India. That I know because they are not never going to approach because there are also some clause. It's not about the merits. It's like clause. They cannot share their secret R&D outside of the US. So
Yeah.
they
Yeah.
are tied up.
True, true. And so over there at UT Austin particularly, let's say, are there internship opportunities for students at India, or do you think, so let's say there's a UG at India and he wants to prepare for a PhD or a career in device modeling just like you. So what kind of, let's say he's in third year, he has his summers, he has fourth year left. What kind of guidance would you give to him?
So I would say that if you want to go for PhD, I won't say that you should plan for internship because suppose if you're targeting for the in a good institute, I would say rather focus on your research. Maybe try to publish a paper maybe not on TED, maybe some solid state circuit, maybe some conference will also work. So the thing is that when they shortage for the PhD professor, when I discuss with them, they try to seek for the candidate who is persistent. They are not looking for the genius. They are not looking for the super genius. They are looking who is the persistent, who can work like regularly, who has shown and he has the basic, he or she had the basic understanding of the device physics. So that they are looking. So if you get a paper, so that will really help you. That will put you on about all applications.
And let's say
Then
someone is not able to get a paper in their undergrad, how can they compensate for it?
then I would say if you don't get the paper, then I would say try to work on the project. Then internship might help. So try to get in touch with, like, maybe in India also they are doing some internship program, like semiconductor devices like Microns and Global Foundry have the internship program. So they
Hmm.
hire intern from the UG, from IIT something, or maybe in any good institute also. So they hire those institutes. So get in touch with those guys. So when you spend like few months in industry, like maybe in good industry, so that is also going to really help you, because they guys here know that if you work with industry, so your thinking is getting broader way. So you are working on the real life problem. So that is really appreciated. That appreciate a lot. And you can also get in touch with like professors here in the US. If you email them, maybe they won't hire you directly in the US. Maybe they won't call you. But if you are like, you are doing some kind of good work, you are really interested, then maybe you can work with them in some projects. That
Hmm.
that
I see.
that is these are the things. And of course they are GRE TOEFL, but right now in US, like many university are not doing, like they are really neglecting that GRE TOEFL GRE score, so they are
Yeah,
not
yeah.
really going
They're
to
just taking TOEFL now.
yeah, so they
Hmm.
are not going to looking for the GREs, so they are really looking on the candidate profiles. So
Yeah.
how's your profile?
And I know what I'm going to ask next. Next, there won't be a hard answer for that, but still, so there are people who let's say they didn't work as much in their first and second year, and they by mistake or by accident they don't have a very good CPI or CGPA, but so now later on they get serious and they start dabbling into research. Maybe they even get a publication, let's say in TED. So and their
Yeah.
CPI, just for numbers' sake, we can say it's like 7.5. So, do you think it would really matter for them, or is it can be compensated, or they should
Yeah,
forget about top schools like MIT and Harvard? They should not even think about it.
yeah, actually, see, CPI matters. I'm not gonna lie that about that,
Yeah.
because CPI matters. So they really look, because as I said that IIT's coursework is designed equivalent to US, so they know that whatever you are reading, like going to the IIT, you are like equivalent to in their coursework. So they look into CPI, but of course, as you said, if you get like you did some exceptional work, like you did, maybe you got some papers, or maybe you did some good project work. So yeah, that can be bypassed. That can be done. It's not a hard and fast rule. They are not going to like they are not only looking for the 10 CGPA guys. Even you can get like in Stanford in UT Austin with the moderate CPA. Given that, but you have proven yourself. Okay, you are not good with the CPA. You did something else good. So
Right. Right.
that
Uh,
is possible, but of course, the probability, if you ask me the probability, it's like I would say I won't,
yeah. Yeah.
I
Yeah.
won't, how much
I
the
know.
probability, but of course, it's always better to have a good CPI.
Yeah. I mean, the higher the better. That's what I tell anyone. But yeah, sometimes it's not possible, right? So
Yeah, but if you work on another thing, and there might be another way, like if you do your not PhD, if you do your masters from IITs, like you do MTech MS, there is another way. So when you do your MTech and MS, then they are going to really judge on your master's degree. So if you do any research work, good research work in the masters, and IIT getting IIT masters from IIT, like they are really look into it. So here getting PhD, if you do any masters from IIT, that will going to really help you. So they are looking for
okay.
those
And
candidates.
let's say someone has a good CPI, let's say around 9.2, 9.3, but they don't have any papers in their undergrad. Would you recommend them to go for a master's first and then go for a PhD, or they should just directly apply?
Yeah, actually, I would recommend them that they should go for the masters, because the thing is that in US getting in direct PhD after UG, it's like the probability is I would say low, because they are looking for the candidate who already completed their masters. So because they in masters they know they already had some research flavor. So maybe you can opt for the dual degree, or maybe you can do the gate and then you do the masters. So that will after doing your master, it will really open you up. It will open a lot of ways for you. Like you will have many ways. You can apply in many institutes. So yeah, I would recommend the masters. Masters will
And
really
I
help.
think even in Europe, they don't take direct UG.
Yeah,
Right?
that is even in US. Not every institute, like there are some elite institute. I forgot which ones, but there are some elite institute. They also don't consider bachelors.
Oh, okay.
So
Okay.
So you and getting masters is definitely going to help in the scholarship also, because here there is no government scholarship. Like there are little to zero scholarship in the US for the government scholarship. Like
Oh,
in
you were
India.
speaking about masters in India, right?
Yeah, yeah. You can also target masters in abroad, but I would say that having masters will definitely going to help you. Maybe you're
Yeah.
not looking for the right PhD
I
after doing
see.
that.
Yeah, I think from my batch also, most of the people who went for a PhD, they did a dual degree like me. And
Yeah.
then there is one friend who's at Caltech right now. He went straight after his UG, but he did really good work in his undergrad, so he was able to get in Caltech.
Yeah, so like in the if you are like talking in the broader ways, I would say masters is a good thing. Like they really hardly hire any UG people directly for the PhD.
Hmm. I
Because
see.
masters also offers them one thing. They are, what I understand that there is a mentality. See, if you did your master, so then you are done. You did once your thesis work. You also had some flavor for the research. So like you kind of at the initial stage of the PhD. So like you had some exposure for that. So it's like kind of hiring an experienced guy.
Yeah, I mean, you're less likely to quit in the middle or
Yeah,
something.
yeah, really, persistence really matter in PhD. So I would say that, of course, like your mental ability also matter, but I would say that most of the people are not looking for the genius. They are looking for the attitude. They are looking for the good attitude and the persistent candidate.
Hmm.
That they are looking. It's sincere candidate. That's all I would say.
Yeah, yeah. So, okay. So coming back to IIT Kanpur, so how do you think the environment at Kanpur, particularly like in India, let's say if someone wants to go into devices, I know obviously Professor Yogesh Chauhan is one of the best. So, what other groups would you recommend to someone? Maybe inside IIT Kanpur or some other groups in India? And
Yeah.
what are some hot research topics right now?
Okay, okay. So I would say that it won't be like maybe no won't be nice idea that I will recommend some specific group, specific professor. I know, but I would say that yeah, in India, if somebody wants to go to devices modeling and maybe experiment too. So IIT Kanpur, of course, there is a really good for the modeling. IIT Madras also had really good group in the device modeling. They try
Oh,
to focus on the analytical things. So they really did some nice work. There was one group in IIT Delhi, but right now the professor is at UGC chairman, I think so. I think
yeah, yeah,
he is
yeah.
not actively involved in that modeling area. And there are some people in Roorkee too, like they
Hmm.
have started their group recently. They have started their group in the device modeling,
Yeah.
and Delhi. I think Delhi right now. I'm not sure that who is really actually involved. Bombay, they have some. In Bombay, they are not involved in the compact model. Like I would say, in like circuit level modeling, like SPICE, but they are involved in the like DFT first principle based modeling. There are people who are working in the space. So yeah, there are some groups. Like in every IIT, you will find one or two professors at least working in the device modeling area. So I would say target to like old IITs. So that would be a nice thing if somebody wants to go for the PhD. And for the circuits, definitely IIT Madras is the top. Madras, ISC.
Yeah,
So for the
yeah.
circuits, these are the two, and Bombay. These are the three you can target for the circuits. These kind of PhDs, and of course target for the PMRF. If you are going into IIT, try to get the PMRF.
Yeah. So yeah, and yeah, yeah, go
Yeah,
ahead.
yeah. Just I will comment on one thing. India, there is one more advantage. Like I observed here from US. In India, we have MSRD funding. So if you get into IT, you will definitely get your stipend. Then of course maybe you don't get PMRF, but you will still get maybe I think right now it's 35,000 something like
Yeah,
that.
yeah.
You will still
It's
get it.
not like that in US.
No, it's not like that in US. So in US, what happened? It's a little bit, little to no government funding. So government, US government not going to fund you at
Yeah,
all.
not government funding, but let's say you're in the top institutes in US. So is it? It can happen that you're among in the top institutes and yet you don't have any funding.
Yeah, it can happen. So what happens,
Oh,
and that's the really big reason that those guys don't hire a lot of PhDs. Even they are interested in your profile because their hands are tight. So what is the process here? That if you apply for the US PhD, so whichever the professor you decide, okay, I want to work with that professor, and he agrees. So he should have funding. He or she should have funding to support you.
yeah,
Like
yeah.
he should have their own project to give you like 2.5 or $3,000 per month. If you don't have, then you cannot hire any PhDs. If in US, if you don't have project, you cannot start your PhD too. That's the harsh truth.
Hmm. Yeah. Okay. So yeah, and you mentioned that at IIT the cost of living was like 5,000 rupees per month.
Yeah,
How is
it's
it at
not.
US?
Oh, it's the US. They see, yeah, these are things you have to compare.
Yeah,
So
yeah.
yeah, it's a nice question. So yeah, it's a nice comparison. So in US, that's what I say. In US, you will get a PhD stipend. So I would say on average, maybe it's 2,200 to $2,500 per month.
It
That
depends
would
a
be,
lot on state as well, right?
yeah, definitely. That's why I said maybe it's somewhere it's 1,800, somewhere it's 2,200. So depend on where you are living in California or Texas, depending on the tax. So if you are getting that much, like suppose you let's consider you are getting $2,000. So yeah, you are not going to save maybe $200, $300 per month. That's all. You are only going to save, I would say 20,000, 30,000 Indian rupees if you are working in the US as a PhD because rent is $1,000, $1,200, something like that.
Yeah, but
Maybe
like in India, the nominal stipend is like 35,000 rupees. And on top of that, people like you who are able to get fellowships and PMRF and stuff like that, they can, increase their stipend. So
Yeah.
here also there would be some avenues, right? Or no?
Yeah, I would say that India, if you are getting 35,000, that is equivalent to US, you are getting 1,500 or $1,800. So
Oh,
that
okay.
is equivalent because here cost of living is really high, like groceries is really high and your rent is really high. So I would say if you are getting PMRF in India, so you can be
That
much
is
richer
fair.
in your PhD domain, in your PhD life. So you can be much richer than US because yeah, you are not going to save your $1,000. That is impossible in your
Hmm.
PhD. So it's like it's
Right.
really nice thing.
Yeah, one
So
of my
government.
friend, he's at Columbia right now. He's getting a really good, it's close to $4,000 stipend. I don't know how, but New York is definitely really expensive, but the stipend is also really good.
Yeah, so maybe he applied for some other scholarship. Again, they will choose only exceptional candidate. So if you apply
Hmm.
for the scholarship, then maybe he's getting one more or two more scholarships, something like that. And right
Hmm.
now, I think Indian also they are going like initially they only selected like 100 candidates from PMRF in 2018, but right now they are selecting a lot. Like their yearly
Oh.
intake, I would say maybe 700, 800 total.
Hmm.
So they are increasing their like the government is want to give the fund for the PMRF, so they are hiring
I
many
see.
candidates.
But in PMRF, I think you have some duties as well, right? Like teaching or some duties.
Yeah, they started. So, from my personal point of view, I never understand the idea about it. I thought that okay, PMRF should be focused on the research, but they thought okay, we are giving you like as equivalent as an assistant professor for the IIT Kanpur. So we are like for the IITs and IIT Kanpur, like we are giving you that much salary. So we expect you to do some work. So that is like. You have to do some teaching assistant work like you have to teach in some kind of government college or maybe it's like it's maybe NPTEL course. It maybe it's like I would say per week you have to spend maybe 4 to 5 hours on that kind of work on an average. I would
It's
say.
still decent amount. It's not small.
Yeah, it's really decent amount for the PhD. It's
Yeah.
like it's spent 4 hours. I would say it's like 3 to 4 hours minimum. So that's the work. So yeah, that's the duty you have to like you have to get the certificate. You have to present on the against the reviewer panel.
I see. Okay. Yeah, and yeah, I asked you about the hot research topics right now.
Yeah.
So,
So right now the hot research topic is that I would say that people are looking beyond CMOS in the devices. I would say so beyond CMOS is like memories domain. Like you can always work in the non-volatile memories domain, semiconductor memories domain. And again, people are trying to integrate machine learning and AI into devices. So if you are good in the coding in your UG data, you are interested in the coding, then yeah, devices also you have an area to work on the coding. So like you
Mhm.
integrate machine learning and AI in the devices. So a lot of people are, a lot of good groups are doing that kind of thing. So yeah, coding is also now getting in the devices. In circuits, we always have like RF. I would say RF domain right now is really they are paying really good money in the RF. So if you are targeting the RF circuits, that will going to help you a lot in the devices. In India, for the Indian opportunity, I would say maybe experimental. Choosing experimental right now won't be a good choice. Maybe after when we get the fab, then definitely it's going to be a really good choice. But we
Mhm.
still don't have the fab. I think we're staying with the modeling domains and trying to analyze the maybe first principle based study in novel devices beyond CMOS devices. That would be a nice domain to get a job.
I
Or
see.
maybe
But in your case, so because if you do some theoretical work, even in India, you would have to benchmark or validate your theory with some experimental or at least TCAT data, right? So, I think in your case, since Professor Yogesh Chauhan he had great contacts and all, you might have easily got experimental data to validate your model against. But some people they might they might not be that fortunate. So in that case, is
yeah.
it still a good idea?
So yeah, actually think it depends. So suppose you are working some state of suppose you are working 5 nanometer thin nanometer technology. So if you have wafer like you are trying to develop a model, and if you don't have wafer for that, like you don't have collaboration with the industry, of course you are not going to have that experimental data.
Yeah.
But if you are working in that modeling area, there are many papers like people publish on IDMs and IEEEs, especially on the IDMs. They really publish state of the art, like industry, like
Yeah.
from Intel, IBM, the Global Foundry. You will always see papers in the IDM every year.
Hmm.
So you can get those experimental data to benchmark your work, whatever you are doing.
I see. I
Like
see.
it's
So, like, there is a tool called Digitizer,
yeah,
I think. So
yeah.
that works, right? That you can just extract data from papers and use it to your whatever use you have. That's
Yeah,
fine,
it's
right?
right. Yeah, you start that reference. You said, okay, we develop this model, we work on this domain, and now we want to validate our mathematics or whatever we did. So we got the experimental data from that paper. So
I see.
like I would say 95% or maybe 99% people do that because
Hmm.
not everybody have. Even if you have collaboration with the industry is not going to share with you like state of the art. They are
Yeah,
not going to share everything with you, right? Now you are industry, you can understand that there are many clauses, there are many
yeah,
things you
yeah.
cannot share. So I think benchmarking with the experimental paper you can do it.
Hmm. I see. Okay,
And
quite insightful.
and even in devices, I think doing PhD in devices is like less more expert nature than the experiment. In experiment, you get lot of randomness. Like you are whichever group you are working, they should have really enough funding. Like your tool is not working, you got out from the materials, from the chemicals, you have to buy it everything. So yeah, like I would say, if somebody is targeting for the experiment in India, they should target Bombay or ISC because they have
Hmm.
centralized, they have like a very really good facility for the
Even
experiment.
in terms of time, you are bounded, right? You have to be there at certain times to conduct that experiment or that
Yeah,
fabrication step.
it's because in every institute it's the central lab. So not only it's not like that lab is not dedicated to your group. So it's dedicated to whole the IIT system, whole the institute because it's really costly lab. They are not going to make like 4 to 5 days kind of labs. So you have to get the slots, and then it also depends on the weather. If it's rainy, if it's like dusty, then the instrument stop to work. Then I think it's maybe when the moist come in the devices, semiconductor fabrication. I think it's a 2 3 month blank period. Like you cannot really fabricate anything. It's something
Hmm.
it had to do with these kind of things. An experiment, there is a lot of randomness. Like that, I would really say that those guys really working really hard. Getting a really good device is take years to getting a good device, working on a good device and getting a good papers. But then you get the like benefit. Then you get published at a really good journal. That is your
Hmm.
that is
Yeah, yeah, right. Uh, yeah, so okay, so let's talk about what you are doing right now in your research. Just very briefly for someone
okay.
who's a layman, like, or let's say college students, how would you explain? And just try to motivate them to pursue a career in maybe devices.
Yeah, so I will also mention one point, then I will discuss about this. So getting like a PhD from devices from my it was really good experience that I got a lot of publication because the thing is that I got excited from my UG days. So that kind of idea I also continued my UG idea in my PhDs. So that paper, getting those papers, and after that EDS fellowship, I think that really helped me a lot. That really helped me to put to the recognition on the on the international platform. So after getting EDS fellowship, I was invited for the talk at the Stanford Engineering in the December 2023. Then also I had one talk at UCSD in December. So those guys invited me after like they are saying, okay, you got the EDS fellowship and these kind of things. So that really helped me. So it's kind of getting to get to know the people. And here the work, what I'm doing. So here the work is again, here the work is right now people are done with like not done. I would say silicon based devices, CMOS based silicon based devices. It's kind of research in that domain is kind of saturated, getting saturated because people are working from on those devices from 1950s. So there are
Mhm.
hardly any area left to publish papers on the conventional silicon devices.
I
So
see.
here what we are looking here that we are also a collaboration with the industry. I cannot disclose everything, but yeah, we have collaboration with industry, the R&Ds. So here we are looking to work on which device we are going to use in the industry or like what type of device they're going to use after 10 years like their FEVL front end of the line. Okay, for the layman language, I would say suppose you want to replace the silicon transistor. So what are the other alternatives you are looking in terms of memories, in terms of speed, and in terms of power consumption? So they are really looking to in terms of scaling that how many devices you can put in a single centimeter square. So yeah, we are looking onto like alternative of the silicons. I would say that our and my work is my work is here is focused on the again theoretical domain is from the first principle base also and again also phase field modeling like I'm here the model which I am working I'm trying to predict suppose before fabrication so what should be like your what should be your rough dimension suppose there is a way what the industry follow here even every industry follows there is one way that you go to the lab and you make 100 devices and then you measure everything then of course you said okay it's one this one is working correctly but this is what we want to current and this is what we want off state then you kind of find out then you proceed with it but that will gonna take a lot of time and that will gonna waste many devices because you get a lot of random and lot of noise in the experiment another way you try to develop a predictive model like mathematical based model or phase field model so in
Mhm.
that will get the rough dimension. That should be the thickness, that should be the length, that should be the doping profile. So if you try to follow those in the experiment, it will not going to exactly match what you expected, but it will get you the closure. So that on what I am working right now. That I am trying to develop the model for those devices. That how like industry they are going to fabricate it. So what should be our dimension? How we optimize the device so that get to the optimum performance.
Okay,
I'm
okay.
not speaking on the experiment. I'm involved in the like predicting the technology note. I would say that predicting the technology device performance. That's my work.
Pretty cool, yeah. And okay, so now after transistors, FinFETs, gate all around FETs, what's next? Where do you think the industry is heading?
Actually, it's that question. I think I remember somebody asked that question from. Yeah, I remember his name. Yeah, somebody asked this question, the same question, a few years back. I think 5 to 10 years back, to Professor Philip Wong. Maybe you heard
Yeah,
of him.
Stanford. Hmm.
Yeah, Stanford. He's a really pioneer in like
Yeah,
devices. So he was giving some talks. So somebody asked from the industry or maybe some academia that, okay, professor, what do you think about that after the silicon? After the most FinFET, what we are going to do? So he was not sure about that time. He said, okay, there are many things like people are schooling, like 2D materials. People
hmm,
are also learning negative capacitance. So I think the answer would come after 5 to 10 years. We are really not sure about it. There
I
are
see.
many groups working on the many diverse area, but that's why I said this area is really like I have said this really emerging area. Like people are trying to really eagerly looking for the beyond silicons. They are really looking into those. So
Hmm.
I would say I'm not that much expert to comment on that. I'm not sure what's going to happen, but yeah,
Yeah, yeah,
there are
okay.
4 or 5 alternatives that are potential internet. I think 2D materials also industry, Samsung and some. I also saw some paper from Intel. They are also trying to get 2D material devices. Like
Yeah.
TSMC also, they are
Hmm.
trying to make the transistor on the 2D material. So yeah, they are looking on the 2D materials. I think that might work. And non-volatile electric based non-volatile memory, people are also looking into those kind of area. Let's
Yeah,
see.
yeah. Let's see where we go.
Yeah, let's see. People are doing that for from. It's been I think 10 to 15 years. I would say it will take maybe. I don't know. I'm not sure because see from the industry perspective, they have whole fab setup for the silicon. So if they are going to change for the like suppose somebody say comes here or they said okay use this material and forgot about silicon, then they have to like destroy all the old instrument because in the fab this is not how this works. Every instrument is like specific for that specific
Hmm.
area.
Yeah.
So then you have to establish a new fab. Then you have to spend billions of dollars. So
Hmm.
it's really hard to convince those guys. Okay, use this instead of silicon. So
Right, right.
that,
And also, I think right now in academia, in particular papers, people have published a lot, but there is no such demonstration of a large yield or for these devices, right? I think the
yeah.
yield is not that high yet.
In academia, most of the time we are only focused on a single day. Like we are just only focused on the research domain. The research happens only for the one device, two devices. Maybe you
Hmm.
make circuits like maybe smaller circuit, like you make op amp or this kind of amplifier, maybe 15 transistor, 20 transistor. And but industry, you are going to talk about the billions of transistors. So when you like those guys really, that's why those are really cautious that what they are going to choose. They really love silicon because in silicon you have like 1 nanometer, 2 nanometer kind of crystality. So crystalline structure, it's really nice structure. So I'm not sure how they're gonna do it, but yeah, it would be really hard to convince them. Okay, go opt out the silicon. That's why Intel, see Intel and Nvidia, they are going to. And also again, it's a nice discussion that's come up. There is one more thing like architecture level engineering. So that's why there are people also focusing on that. That we are going to stick with the silicon and we are going to arrange our processor, our architecture in that way
Oh,
that can come up, that can meet the scaling requirements. So that they are going to arrange their transistor, their circuit in the stacks in some kind of like engineering way. They are engineering their architecture level to
yeah.
stick with the silicons and we are going to enhance the performance.
Yeah, I think like it was a big jump when we went from 2D flash to 3D NAND flash, right?
Yeah, that was a big jump, and that's what the Nvidia is doing really good compared to Intel. If you see the recent news, have you heard about that Nvidia is ruling really great.
No, no. Oh, yeah, Nvidia doing great. Everyone heard, yeah.
Yeah, Nvidia is ruling really great. So why they are doing that great? So they are really focused on their architecture. They haven't changed anything in the devices level. They
Oh,
focus on the architecture level design. They really put their effort on that. So they try to like that's why their the processor that the graphics card GPU is really fast. So yeah, they are really focusing on that architecture level. So yeah, they are not looking for the intelligent material right now. So that's also another domain to focus ourselves in the architecture level of engineering.
yeah, yeah. So
Stay with the silicon and play with the architecture.
yeah, I mean, so there are so many things from circuits, devices, systems. That's why I think like if someone wants to start a company or a startup in this domain, it can be really hard. What do you think about that?
Actually, if you want to start a startup domain in the semiconductor, so I won't say you start on the devices because in devices there are billions of dollars of requirement. I would say the initial point should be like designing circuits, like not really fabricating that, but supporting the industry. Like you design their circuit, like you design drive the algorithm, you analyze that circuit, like you do it in mental graphics and cadence, something like that. Then that would be feasible thing. Just to like because that will require only few computers, it's but it will require smart people because designing circuit, it's really not an easy task. Like there is always trade-offs. So I would think that for India, and I think that would be the nice point to start. You stay with the analog circuit or RF circuit, but again, don't do the fabrication. Try to design, optimize the devices using tools and using your own mind. So that kind of help
I
you.
see. Yeah, like develop IPs and then sell them to other businesses or companies.
Yeah.
Right.
Like
Okay.
you work as a vendor for the companies, for the experimental guy, like those guys are working. So they will hire you. Okay, we want to analyze this circuit. So how you gonna do it? So when you try to do this kind of work, it's like yeah, you can sell your own IP, you can file the patent, then they will use it, then you will get funded. That would be the
Hmm.
thing. In
I see.
experiment, like if you cannot start at the initial points.
Yeah, that requires a lot of capital just to
Yeah.
begin.
Yeah,
Hmm.
even if you want to like make a single device, it will require many crores. If you just want, even state with the single transistors, no, you are not going to
Yeah, I
fabricate.
remember once Professor Yogesh Chauhan, I did a course like compact modeling with him, and he was telling about all the machines, how much they cost, and
Yeah.
they were like in crores, right? So,
They are in crores, and those are not fabrication machines. Those are only for to measure. Suppose you
yeah,
buy the
yeah, network
they are
analyzers. Then.
they are importing the transistor from industry, and they are just measuring their like current voltage characteristics at the device. Of course, that is on the device level, on the nanometer scale, on the RF scales. So there are number like I would say maybe few crores of the machines, and then there are running costs. Like if you like one instrument gets short circuit because those are the RF instrument, you have to pay 10,000, 20,000, $30,000, something like that to get one plug, to get one RF amplifier. That is how they so that is and see here we come the people at the industry which are selling those RF circuits with connectors. They also require those modeling those circuits guy to design that. So they have their IP. So now they once they establish their like platform, now they can sell it how much they want. So yeah, doing experiment is really there is also running cost. I think after some point running cost matters a lot.
I see. Okay. Oh, so I actually took a lot of your time. I'll just take one last question, a
Sure.
cliche HR question, like where do you see yourself in 5 years, or let's say after your postdoc here, and what
Yeah.
concluding remarks would you give to everyone?
Okay, so for myself, what I see, what I'm looking right now after my postdoc is that I'm looking for to get some exposure from some industry R&D groups here because still like in India there is no device R&D group focus on the devices. Like I would say there are modeling groups, but like what you are going to do after 10 years. So here there are some groups which I am involved with this. So I will try to get a job maybe for few years. Then after that, definitely I will try to get back to academia if it is like if everything will go smoothly, then I will try to get back there. And for the like for the other people like who are trying to do targeting their PhD, I would say that if you are interested, really interested in the devices, then it might be a good idea stay in India, get the PMRFs, and do really good work and try to do your masters initially. So that will open a lot of ways when you want to do the PhD in the US and abroad. And if once you get in PhD, try to get the scholarship because even if you get your PhD in US, like it is not going to put on the like top of the people. So you have to do some extraordinary work. You have to do some and not extraordinary. I would say persistent work. So do some good work. Try to get some good like awards. So yeah, that will help you a lot. I
Okay,
would say
okay.
that.
Yeah, all right.
Maybe, maybe for the UG guys, maybe for the UG guy, maybe it would be a nice idea to focus on your CGPA and try to get in a try to do a master's. If you are already in IIT, opt for the dual degree. If you are not in IIT, try to do give a good gate exams and get into the master. So it will give you a good exposure. Whether it will also help you decide whether you want to go for the PhD or not. Masters will help.
Yeah, makes sense. Okay,
Yeah.
so thanks a lot, Nilesh. I think this session would help a lot of people. and
Yeah,
you
I
can
hope so.
get
Let's
some
see.
value in this one.
Yeah, sure. I hopefully that will help a lot of people. Let's see.
Yeah. All
Thank you
right.
for having me. It's been really nice. So I am really glad to have you here because I know your podcast is getting famous.
No, 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 it's
So
not famous yet.
yeah,
Maybe
it will.
soon.
Yeah, maybe soon. I really hope so. So I also seen your videos and thank you. Like you invited me. It's been really nice to talk to you.
Yeah,
Thank you.
it's
But
great to catch up after long.
yeah, sure. Hopefully you will get a lot of many other guys to brilliant guys. Those can help the other students
Yeah,
because
yeah. Right. Thanks.
thank you, Tejas.